We are live. Christine Williamson, thank you so much for being here.
Thank you. Thanks for having me.
This is exciting because yesterday we celebrated 10 years in business as a conscious builder, and it's been an
Congratulations.
thank you. It's been an evolution as we've gone up, as we've grown as a business, and I've grown as an individual as well. So it's exciting that we're here with Building Science Fight Club talking about this on our 10-year anniversary. So thank you so much. I'll give a little bit of background for all of our viewers out there. Christine Williamson has spent her career in building science forensics, discovering why buildings fail and working with others, architects and builders to remedy the problems. Her new construction consulting helps architects and building science not only to mitigate risk of failure, but also to help them make their projects as energy efficient as they are beautiful. She is a founder of the Instagram account Building Science Fight Club, an educational project that teaches architects about building science and construction, and currently has, I just looked it up, 41.1 thousand followers. So she is helping a lot of people.
45.1.
Sorry, 45.1. I read that wrong. Dyslexic.
I check it every day. I check it every day. Yeah, whatever. For what
Christy
it's worth.
graduated from Princeton University and studied at Boston Architectural College before completing her Master's of Architecture at NewSchool Architecture and Design. And she's also the chair of the ASHRAE Technical Committee 1.12 Moisture Management in Buildings, which is very important, especially when we get into building science and making super energy efficient homes. So once again, thank you, Christine.
Thank
You
you.
are a wealth of knowledge.
Well, thanks. Thanks. It's fun to be here on your anniversary.
Yeah. So I'm excited to talk about this because a lot of where we put our focus as the conscious builder is into all the stuff that you can't see, right? All the stuff that goes into the walls, which in my opinion, and I'm sure you agree, is like the most important part of a building. It's not the only part, but it's a very important part. And obviously there's other things that come into play. But that attention to detail, all that stuff that you can't see just plays such a huge role in the overall comfort and efficiency of a build and health of a building.
Yeah, I think of it a little bit like an iceberg, where the finishes are the part of the iceberg that's above the water, and that's the stuff that your owners see and experience as they live in the building. And it's also what they imagine your job is as a designer, is to kind of help them with all of the stuff that they see. But the stuff underneath the surface of the beneath the surface of the water, that biggest part of the iceberg, is all of the stuff that you don't see. The and that you're essentially, as the builder, the architect, you're responsible for all that, but you don't get a lot of love and appreciation for it. It's just sort of assumed that you will figure that stuff out. But it's also the stuff that makes that's the scariest too. The stuff that what is it that I don't see that's got me at risk, and how do I manage that risk? So I don't know, I like the iceberg analogy.
Yeah, that's a really good analogy, and it's an important point too because it's like human nature. We don't like to pay for what we can't see, right? So uh, I do not envy architects and designers having to basically do all that back end work, like even the design portion, right? The homeowner all of a sudden gets a picture, and they're like, "Well, why did this take so long?" You're like, I took like a day just to do that one little detail, but they don't see it, right?
Yeah, I mean, there's a lot of stuff like that in construction and building too. Like I was looking at somebody's work on tile layouts for showers, stuff that's normally stuff I don't think about at all. Those types of finishes, but when I did my own house and my contractor did the tile layout in my own bathroom, he spent so long on it and he did a terrific job. It was one of those things that you don't, if it's done well, it's obvious. It's like, of course it should be like this. When it's done poorly, you will notice, or maybe you'll notice, maybe you won't. But when something's done well, we just sort of expect it. We don't always appreciate it. But there's hundreds of thousands, I think, of examples of that in our business.
Yeah, for sure. The tile, that's another great one. Like, and that's one of the reasons why I always push, or I promote hiring an interior designer. I tell people, I'm like, look, we're not an interior design firm. We can't sit here and spend hours and hours figuring this stuff out, but it's important and we need to figure it out before, because we need to like put the rough-in valve in the right spot
Yeah.
that lines up with the tile layout, and you know what I mean, or that it needs to be framed so you can have your niche perfectly to work with your tile. And just because your tile is 12 by 24 doesn't mean it's actually 12 by 24. So
Yeah.
we need to figure out a lot of that stuff. So that's all important parts, and once again, you don't see, but at the end of the day, you realize it, right? You don't see what goes into your walls, but you feel it. You don't see what goes in the design of the tile, but you then, every time you take a shower, then you see what could have been caught.
Yeah, and some stuff you never notice, and some stuff you will, and or you won't, and maybe you won't notice until it's wrong, or you won't notice until you have to do it yourself, and you're like, oh, this is a lot more work than I thought. But yeah, that's why we get paid the big bucks, right?
Yeah. So what's your like? I'm definitely in touch with the construction world, and I see kind of where the, you know, I sit around tables with bigger builders, and then, well, now I don't really sit around tables. I sit on Zoom calls and web conference calls with other builders, and I kind of see what's happening in the industry. And you know, there's still a lot of pushback and back and forth on, you know, building to a better standard, right? And what does that mean, and what are the requirements, and how do we manage that, and, you know, net zero and so forth. What is it like on the architecture side? Like I'm not very in tune with what happens in that world.
Oh, it's the Wild West out here. I mean, I don't know. It's everybody's experiences, I think, are so different. It is sort of the Wild West in that it's really dependent on what your firm's niches and what types of customers I think that you end up attracting. There's plenty of code minimum buildings out there with pretty decent finishes and finish packages. So owners might not necessarily know what they're getting from a performance and durability perspective. And then there's an entire end on, you know, so that's one end, like code minimum, which increasingly looks nicer. Like maybe it isn't nicer, but it looks nicer. So that's, we've got one end there, and then, although those typically don't involve architects. And then on the other end, you've got these incredibly designed passive houses, or just luxury houses that aren't pursuing any kind of particular standard, but are just the scale and the mass makes them their own category. I've definitely worked on a lot of, like, a shocking number of billionaires' homes where the standard, all that stuff you don't see, are less than what I would consider mid-range kind of commercial multifamily construction. Like, you know, not even nice, like not even luxury apartments, just the standards you would see on, you know, generic
Mhm.
2 or 3 story townhomes going up, is nicer, like substantially better than what I'm seeing on these, you know, 15,000 square foot homes. It's crazy, but they don't know, right? And you get people who hire. It's, our industry is so segmented and so specialized, which is, I think there are a lot of really good reasons for that, and there's a lot of positives, but the drawback to that is that just because somebody is good at one thing doesn't make them good at another thing. So if you're an owner and you're looking to hire somebody, what are you using as the basis of that decision? And a lot of times owners gravitate towards things that they do understand. So they pick somebody whose aesthetic they like. Well, I like the kitchens that you design, therefore I'm going to hire you to design my whole house. Well, just because you're good at kitchen design doesn't necessarily mean that you really know what kind of insulation that they should use, or
Mhm.
not just picking materials, but like what the design of the walls should look like, what the connection should be between the wall and the roof. And even if you know what's good, like what are some possible alternatives that your owner might want to consider? Like, just because you're good at one of these things doesn't make you good at other things. So it's really hard, and it's hard on both sides. It's hard as an owner to know what, like how to evaluate people. And then it's hard as a designer to know you're responsible for all these different things. You can't possibly do everything like at 110%. So how do you choose what skills to develop? When do you bring in outside expertise? Those are hard decisions, and people make them all the time, but it gives them a lot of stress usually.
Yeah.
Did I do the right thing? Am I can I figure this out on my own, or do I need other help?
Yeah,
They're
it's
hard.
always, it's like I always tell people, I'm like, it's amazing that anything gets built, right? If you think about everything that, all the people involved, all the decisions that need to be made, all the things that could potentially go wrong when designing and building a building, no matter what it is, it blows your mind. And to expect that it's going to be problem free or speed bump free, so to speak, is somewhat setting yourself up for failure too, because there's so many things that are just out of our control. Right.
What's
So
cool, I think, is like nobody actually knows how to build a house. Nobody, not one person. Like it's expertise that exists in a whole bunch of different people, but not one person, even on a simple house. Now, there's some exceptions. There's like I don't know, pioneers who literally did everything. They like actually chopped down the trees, and there you go. They started from actually from scratch. But modern frame
they didn't
building,
have mechanical systems in their houses yet.
they did not. But they also even if you were to build a house completely from scratch, you wouldn't be using dimensional lumber. You'd have to forge the nails yourself. Come on, nobody really knows how to do this. So it's sort of magic to draw on all these different areas of expertise and technology and human ingenuity and advancement. And even though no single person knows how to do it, we like magic, just build a ton of them all the time. They come together and
Yeah.
we're pretty good. There's a lot that's wrong with a lot of homes and a lot of commercial buildings. I work, you mentioned in my bio, I work a lot at investigating building failures, and there is no shortage of work for me to do in that area. That said, what we are able to do relatively inexpensively is astounding. The cost of building single family homes is it's so low, and what we produce as a result is better than at any other time in human history. What we're actually expecting when you're building sort of a standard code compliant house, you're actually providing an extraordinary interior environment for people. It's very cool.
Mhm.
I'm very impressed with the industry as a whole. I mean, we've got a long way to go. Don't get me
Yeah.
wrong, but we also have great people who are doing great things and pushing the market to different areas. Homeowners, I think, are starting to have a real sense that there are differences in who you hire to design and build your house, in the how comfortable you are in that house. Those things are actually connected, and I think we're starting to see that more broadly. How many people do you get? How many clients do you get saying indoor air quality is a really big deal for me?
Yeah.
So how
Well, we've
design me a
marketed
home like
ourselves
that?
that way too.
Yeah. And that's not always been an option for us. We used to not have air control. We
Right.
didn't have anything. We didn't have these membranes that we could use to very very well separate the inside from the outside. Well, we know how to do that now. There's a lot we can do. It's very impressive. Lots to do still, but
So you packed it. You're saying a lot there and brought up a couple questions. So what are the most common failures that you see in buildings?
water. It's always. I mean,
And
so
where is that water coming from?
it's funny. Sort of the
And actually, sorry, are you only working in your area? Let people know where you're working, maybe, because where you're working might be a little bit different than where they're living.
I work in Dallas, but don't hire me. I'm not taking any new clients. But I work everywhere. I'm based in Dallas. It's the middle of the country, so I work in all climate zones, and it's very convenient to be in Dallas because it means I can be on the West Coast in a couple hours, the East Coast in a few more. So it's pretty easy. But yeah, so we're pretty good as an industry, fortunately, at making things not fall down and making them not burn. We are very, very good at this in North America. It's we owe an enormous debt of gratitude to the professionals who develop our fire codes and our structural codes, often on a volunteer basis. We are very good at this now. Now, nobody's perfect, and it's very, very sad when we make mistakes in this area, but we have come a really long way, and it's nice to see as an industry. For example, the devastation after Hurricane Andrew in Florida in, I think it was 1992, versus Hurricane Harvey in, was that the one in Houston? I think that's the one in Houston I was thinking of most recently. It's very, our buildings fare much, much better now, and that development is not accidental. So there's lots of really good advances in structural protection and fire protection, but and that's natural. The things that will kill you deserve priority. I work on things that annoy you and maybe get you sued or cost you money. And kill you slowly. So worry about the things that kill you quickly first, and then the things that annoy you or kill you slowly. So the biggest non-structural, non-fire related failures have to do with water. And believe it or not, it's almost all the simple stuff, flashing details, really keeping rainwater and groundwater out of the structure and allowing, when rainwater and groundwater gets in, allowing it to dry. It's almost always, the failures I see are almost always a version of that. It's a fundamental error in just, well, we didn't keep the rainwater out. We were missing a piece of flashing. We didn't connect the roof to the wall. We didn't connect two things that were supposed to control water together, which is very common because you don't just have one person building a building, you have all these different trades coming together. So your roofer only does the roof. The guy installing the windows, that's all he does. So it's, we have specialists, and where these specialty trades come together is where we tend to have failures, but they're almost always failures in bulk water control. It's less common, but still happens, where there's other types of water failures that have to do with condensation control. And that definitely happens, but it happens a lot less than just bulk water management. And then failure to manage rainwater and groundwater creates all these other things, like domino effect, where you get mold in your walls. You might have structural failures as a result of water failures, balconies collapsing, unfortunately, as well. Stuff like that, but it's almost always just simple flashing.
So yeah, because I think like the second thing you mentioned with regards to moisture control, condensation, that sort of stuff, some of that might not come into play until you get into the high performance buildings, and there's a lot less of those buildings. And I feel like any of those issues are going to start showing themselves in years down the road. Because like even the first passive house that we built, we put things into place to prevent that sort of stuff. But if there is an issue, nobody's really going to know for years, right? So
yeah, and it's what's interesting though is that even the regular energy code or regular building codes that sort of draw on the energy code, they are becoming more and more strict, which I think ultimately is a very good thing for our industry. But what it means is that if you were a builder, you've been doing this for 30 years, and you previously didn't pay all that much attention to the wall-to-roof connection or how you were installing your windows, well, now when you switch from 2x4 framing to 2x6 framing, and you have an extra space in that cavity for insulation, so there's more insulation. Well, what does more insulation mean? It means less energy flow, which is good. Again, it's a good thing. We want to keep heat outside or inside, depending on the season. But less energy flow means less drying. So that we're having to adapt as an industry, even in bulk water management scenarios, where stuff that we could do before, we could get away with being less attentive before, and now we can't. And that's definitely true, as you said, with high performance homes. And people who are doing this, they know, okay, I'm building a high performance home. There's not going to be a big I don't have a lot of drawing potential here. I've got to be really good at what I'm doing. And expectations, I think, are higher all around, everybody involved in them, right? People know
Yeah.
I'm working on a high performance home. The owner, I'm paying for a high performance home. I'm paying for this kind of expertise, whatever. Everybody knows about it. But it's also happening on non-quote unquote high performance homes. And that's where we see a lot of failures, because a home is a system. There's a lot of interconnected parts, and you could do the same thing that you've always you could think that you're doing the same thing you've always been doing, but it's not the same anymore.
Right.
Like classic example is stucco and failure to provide a lot of drainage behind your generous amounts of drainage behind your stucco. If you're building a one-story bungalow, maybe you were fine with the 2 layers of building paper, which is required by code behind your stucco, and that gave you enough drainage and you were fine, and you did it for a whole bunch of years and never had a problem, and all those houses were fine. But then you decided, well, hey, the market is more into these urban townhomes, and you switched to a more modern construction without overhangs. And you said, well, instead of little 1-story bungalows, I'm going to build 3 and 4-story modern townhomes, and I'm going to do it the same way because I know that way. I've got lots of experience with that. And now suddenly all of the sheathing is rotting after a few years, and you've got owners on the hook for a whole lot of equity and big lawsuits and all that stuff, even though nobody broke the law, nobody violated code, and they did what they were experienced at. They weren't new.
Yeah.
But
I was talking with somebody about
scary.
that last week about how if you look back to the way the houses used to be built, and they have overhangs and steep sloped roofs, at least where we live, and front porches, like all these things to keep the weather away from the house in all aspects. And then all of a sudden now new architecture is like, well, we're going to challenge Mother Nature, and we're going to put no overhangs and flat roofs and large pieces of glass, and then we wonder why we have problems sometimes. But
and we want to do it with moisture sensitive materials.
right.
Like it's one thing to do it with concrete and block. It's another thing to do it with wood and engineered wood too, no less.
What's typical for building in Dallas? Like, are you doing a lot of concrete there, or is there wood in your residential buildings?
Yeah,
Everything we do is wood frame.
So almost everything in the United States is wood frame. The big exception is Florida, which is actually terrific for Florida. And I wish that more coastal regions that get a lot of hurricanes did this. But in Florida, they do, they build with block walls on their first floor. And then the second floor is wood framed. So it makes it much more resistant to flooding. So you get a flood, and at least you get to keep the structure.
Right.
In Houston, there's a flood, or New Orleans, or anywhere really on the coast that's prone to flooding, you get a flood on a wood frame building, and it's just a real bear to remediate after that kind of stuff. But pretty much everywhere, it's residential buildings are wood framed throughout. In the South, and a lot of the South, we build on crawl spaces, which is quite different. So we have like mini basement space, likely like only a few feet, which is frankly sort of stupid way to build, but it's really common. So that's what we do here.
This is Building Science Fight Club, so you can use those strong words.
Indeed. But no, I have a crawl space in my house, but it's a little bit, it's really old school. It's essentially an attic. You're building your house on top of an attic, but it's underneath, and it's vented to control moisture. My house is so old that the floorboard, I conditioned the crawl space just recently, so this is not the case anymore. But if I dropped there's no subfloor even, it's just the floorboards right on the framing. So if I drop a penny between the floorboards, it falls on just dirt.
Yeah.
Just there's a cavity of 18 inches and then dirt. So it's not very efficient. But crawl spaces are common in the South and wood frame, and then of course in the North it's more slab on grade and then actual basements.
Yeah,
but we got tons of room here, so why would we build a basement? We just build a bigger house. Lots of room.
Yeah, it's true. We basements are really common where we are too, but recently there's been a couple houses that come up where the basements just didn't make sense because like in Ottawa, a lot of lots sit low. So if you want a basement, especially on the rural, like in the perimeter, like you're building your lot up in order
Huh.
to get
To
the basement.
accommodate a
So
basement.
people are, so I've had a lot of conversations like that because we do like custom homes and like they're like, well, we want a 2,500 square foot bungalow. I'm like, all right, well, do you want a basement too? They're like, yeah. I'm like, all right, that's a 5,000 square foot home, just so you know. That's the first part of the question, first part of the conversation. But then I said, well, we're depending on where you build, you could spend a lot on building your lot up just to have that basement. It might make sense just to do a slab on grade and maybe do a little bit bigger house or a 2-story house because of that. And we've actually made that
Is
happen on a couple.
is that why? So do you not just go lower because you want to be above the water table? Is that why you're having to build a lot up? Like, why can't
No,
you
they're
just go
just
down more?
Ottawa's like in a valley, right? So a lot of our lands, like there's a lot of farmland around where I live, like it's just low land. So you're above the water table, but if you want to build a basement, you end up going down into the water,
Oh,
right?
which is
So
why you build it up. Okay.
so the
We see,
lot has to be built up.
or you could spend a lot of money building below the water table. That's
Yeah.
very complicated.
Yeah. But
I've
that's all, yeah, all
had my
sorts of
share
other
of
issues
that.
with it.
Yeah, that's crazy stuff.
So, anyways, side note, where do you think, like you mentioned, we have a long way to go in the construction industry. Like, in your mind, where do you feel we have to go as an industry, or how do we even get there?
I mean, we don't have to do anything, but it would be cool if we did because there's just a lot of, there's a lot of potential. I think the biggest potential right now is in air sealing. From a practical perspective, energy use, and I'm just going to speak, energy isn't the only thing to be concerned about, but energy use in residential buildings has been steadily decreasing for a very long time, like since the 90s. We use less and less energy in our homes, and we use less and less energy by every metric. So energy use per square foot is down, but energy use per household is also down, and energy use per household member is also down. So we've been getting so much more efficient at how we build that it's more than compensated for having bigger homes and having fewer people living in our homes. And we've mostly done this without really even trying. And the reason that, in my opinion, that we can attribute an enormous part of the energy savings, this is in the aggregate, that we've already realized to better air sealing. We are better at keeping the inside air in and the outside air out. And we are just scratching the surface in that respect. Now, this is really kind of basic for people in the high performance home area, realm of our industry. So passive houses, like all over this stuff, getting low air change numbers at low blower door test numbers. But it's basically about creating, what we're wanting to do when we build a house or any building is we're wanting to create an interior environment that's special or distinct in some way from the exterior environment. And the first step to doing that is actually enclosing the space. So how good are we at separating the inside from the outside to allow us to be the most efficient at conditioning that enclosed space? And so far we've gotten a lot better, but it's, in my view, that's still the lowest hanging fruit for us is in air sealing. Now, in addition to the energy efficiency benefits, and this is why I think this is just really going to continue to improve, that in addition to the energy benefits, the houses that are air sealed are just noticeably more comfortable in so many ways. They're quieter. They don't have odors that you smell outside. When your neighbor is annoyingly using the leaf blower at 7 a.m. on Sunday morning. So you don't smell the gasoline from that. You don't hear it as much. It controls pests better. You get less dust and allergens. If you've got asthma in your family, it's absolutely noticeably better and more comfortable to live in these homes. They're not drafty. They're more thermally comfortable. It's
The,
it's just shockingly better.
The
and noticeably
analogy,
better.
yeah, the analogy I like to use is like wearing a big winter down jacket, right? The jacket is kind of the insulation, but if you unzip that jacket, it's useless, right?
Exactly.
So the air sealing is that zipper in making that happen, and that's what ultimately, it's not the jacket that keeps you warm, it's the jacket and the zipper that keeps you warm.
Yeah, exactly. And it's actually, if you rank like priorities in energy efficiency, if we use energy efficiency sort of as a proxy for these other things, the number one factor influencing energy efficiency in buildings, all buildings, is glazing ratio. So how much glass are we using and how good is the glass? That's more relevant in commercial construction, because in residential construction, for the most part, we don't have the same sort of demand for these all glass residences. I mean, they exist, but for the most part, we don't. Our our windows are about, um, on the high end, 30% of our walls. That's on the very high end, but they're between 10 and 30%. Anyway, so that's the number one factor. The second most important factor is air sealing, and then the third, after air sealing, is insulation. So that's surprising to a lot of people. They think, well, the most important thing is having the down jacket. Um, that's next on the list. The most it's not as important as the air seal. So you're
So
better off, I guess, with a zipped up jacket that's not down versus a down jacket that's not on your body very well.
yeah, no, and I totally agree. Like I have a lot of these conversations with people around windows and doors are big conversations, and obviously I put a lot of emphasis on that and the importance of that. And then the air sealing. So how how do you find though, like as an industry for us, it's easier. Like when we do a lot of carpentry work in house, but on a bigger project, like a custom home, we're going to sub out the insulation, but often we take care of the air sealing details because our crew knows how to do it, and having to train guys that are coming in basically doing piecework is a whole other story. So how do we train a whole industry that every day I look at projects and I'm looking at like the tape you're using isn't even the right tape. Like you know what I mean? Like where do we go with an industry that's been doing it one way for dozen, I don't know how many years at this point. You probably have a good idea, but
Well, they
and basically
haven't. They've just been doing it a way, like not one way, just they've been doing it dozens of ways or not
true.
doing it. Um, yeah, it's hard. I don't know that there's really a single answer to the question. I think it's a lot of different people are going to be figuring out how to make air sealing work on their individual projects, and I hope that on the consumer side, people start asking for this more. Um, Now that's really hard when for example, when you're a first-time home buyer. What are the things that you look at? You're looking almost exclusively at finishes. If you're, especially if you're young, first-time home buyer with a very limited budget, you're not asked. And even though I know the industry, I was like this too. I've been in this house for about 5 years, and it's my first one. And I mean, I wasn't paying attention to what the grading on my site was, or I didn't pay attention to any of that stuff. I mean, I noticed it, but I was like, yes, I will have to deal with that later. What am I going to solve the problem in front of me now? And I'm thinking about what neighborhood I want to buy in and what location I'm in. Those were primary questions. And the sort of how is this built and how am I going to renovate it and how do I want to maintain it were secondary questions, for better or worse. And people are like that. And I don't think that's really going to change. Think that interior comfort, dust control, pest control, indoor air quality, acoustics, that I think will and already is starting to be more of a concern for homeowners. And when clients actually ask for it and seek it out and find builders who know what they mean, they're like, oh yes, those things are related to air sealing, and here's our approach as a company toward doing that.
Yeah.
um, that helps. But in terms of actually how you manage that on the builder side, I think that looks like a lot of different things. I mean, there's some, and it depends on your design too, right? is your attic vented or not? That's another thing you mentioned about in the South. In the South, we put our mechanical systems in the attic. It's very,
Yeah.
very common here. And that's a really different approach. And it means that it's way more important for your ducts to be sealed. And it also matters like how airtight if you're venting your roof, how airtight your ceiling is really matters. And there's lots of different approaches you can take to the design. And that's going to influence like how you manage that, how your crew manages that. But I do think that it's mostly, that ends up being, these are system-wide things, and they extend past the individual trades. So the person who's best positioned to do that, or the people who are best positioned to do that, are people who sit outside of an individual trade. So the general contractor and the architect, if there is one. So architect actually paying attention to this and providing some design details at the outset, like this is how we want to connect the wall to the roof. This is how we want to connect the foundation to the wall, that kind of stuff.
That's actually one of the reasons I like to be involved. Although we're not designers, I like to be involved in those initial design details, because I tell people all the time, like, I know you like to see a price. I get it, right? But we're an open book. We have our fees, and our fees are our fees. We're going to get quotes for things. But if you bring me on earlier, I can sit at these meetings, sit on these Zoom calls now, and work through these details and make sure that we do a detail that, yes, it makes sense on paper, but we can actually build it in a way that that's cost effective as well. Right?
Exactly. And the earlier you have the conversation, the less costly it is to actually implement. Absolutely. Which is super, super important. Most of the time, I think if you're working with a good builder and a good consultant, if it's somebody like me, we should be able to actually save money in this. Now, there's going to be things that you're going to want to spend money on, but for the most part, we also identify things that you do not need to do. Like, well, here's a more efficient way of doing this, and you being involved sooner lets you identify those things early on. Yeah. Because if you price something into the job that you don't actually need, the owner gets very little credit for that, if any, right? Yeah. But if you fail to price something and then you have to add it later, that ad is super expensive. So it's walking this tightrope of estimating, and always better to be involved early. I agree.
Yeah, for sure. So one thing I do want to point out to everyone who's watching or listening right now is we've been talking about air sealing with regards to, the comfort of a home and insulation to the outside, but in a multi-unit building, air sealing is equally as important because of sound that Christine had mentioned, and those smells from your neighbors too.
And it's disgusting, but pests. Seriously.
That's a good point.
Oh, yeah.
So
you don't want to things you don't want to share.
Whoever you're working with to build, like, there should be as much attention to detail for air sealing between units than there is between the indoors and the outdoors.
Exactly. Compartmentalization, very important in multifamily.
All right. So I could keep going on this, but I am conscious of the time. I want to share my screen. You have a couple posts that we pulled out from your hundreds of posts, and let me share that.
Do I have hundreds of posts? I'm going to see how many posts I have.
I think you're in, over 200.
I do. Yeah. 224, it says. Wow. I've been busy. I only post once a week, so it's a lot.
So, conscious uncoupling. Instead of me reading through this, maybe give us a little bit of a rundown of where this came from and why it was important enough to put onto your Instagram.
Well, I'm glad you asked. Gwyneth Paltrow, style icon, popularized the term conscious uncoupling when she was getting divorced from her rock star boyfriend, Chris Martin of Coldplay. And obviously this is a very big cultural event that is of high importance, so it required commentary from me just a few years late. But in all seriousness, I always used to sort of laugh at the term uncoupling because it's an engineering term. It's disconnecting two systems from each other essentially, but it's been hijacked by a celebrity essentially, and I always thought it was funny. So it's an engineering term, but I thought it applied to essentially what we want to do in framed wall construction, and that is that we want to uncouple the cladding of a building, whatever that cladding might be, from the rest of the wall assembly. And it's particularly important with reservoir claddings like brick that hold a lot of water. So essentially it describes that if we drain and back ventilate our claddings, so this is the principle at play here, is if we drain and back vent our claddings, we reduce the loads and the stresses that we put on everything behind our cladding. And that's very important to us because we build with moisture sensitive materials. So the more that we can reduce the stresses and the loads that those experience, the better success we'll have and the more durable they will be. I asked Gwyneth Paltrow to comment on this post, but she did not. I was disappointed. I actually was I was genuinely, I figured she wouldn't, but a small part of me was like, yeah, maybe she will, I don't know.
Never know. She might just be behind on her messages, right? So
that's right. She might still. I didn't message her directly. I don't even know if I could do that. Maybe she has it disabled. But I tagged her in the post to see if she would comment and she would enjoy the architectural version of her term. Some people took this really seriously, by the way, and were like, she's unscientific for a science page. I'm disappointed in you. I was like, it's just a name. Calm down. Not just having some fun with the terminology.
I'm sure you're getting lots of comments. Well, actually, we kind of talked about that. You weren't getting as many as I thought you might be getting on people kind of. There's obviously people out there that tend to pick fights as opposed to add value to posts that no matter who.
Oh yeah, I get very little of the nasty stuff, and I think it's because
Trolls.
we're in, I think, a kind of community that makes that a lot less likely. It's for the most part, this discussion is people using their real names. And they're professionals. There's about 115,000 registered architects in the United States, and that's not a big number. So we're in this community, and I think it's a lot less likely that you're going to misbehave when you're in a professional community that you live and work in and that you care about than if you're some sort of anonymous whoever.
Yeah,
on the internet. And people don't realize, I think, in a lot of stuff that like little babies, when they're too young to realize that you can see them back.
Yeah.
Like they don't know that they stare at you and they don't know that you can also see them back. I think that's sort of some of the dynamic on in some of these online communities where
it's like when I used to put a bucket on my head and think nobody could see me.
Yeah, well, they don't realize that they're commenting on somebody real's work.
Yeah.
Like, so when you post something online and you're you too, like if you're showing your work or a kitchen design or whatever, like that's your work. So if someone is like, man, that is ugly, and they tell it to you, like maybe that's what they think, and okay, that's fine, but you share things differently when you recognize the humanity of the person behind it, and I think that ultimately that is usually a very good thing.
Yeah, no, absolutely.
So I don't get a lot of the haters.
So to add a little bit to that uncoupling too, I think that's a really important point, because I think a lot of, like, in the industry, you understand that there's different barriers, and like the brick on the outside isn't your waterproof exterior barrier. But if people who are not in the industry don't necessarily understand that, right? So I think it's the people who are watching this, it's important to understand that that's really just the first line of defense to some extent, right? And the pretty makeup that we were talking about, but everything has to happen below it. That's where all the flashings happen. That's where the air movement happens. That's the important part with regards to the water control that you were talking about earlier too.
Yeah, I like to describe it to people in. I get them to think about a castle. like back in the day, how we used to build like some medieval castle, and the castle has one layer in the walls, and it's stone. And that stone does everything that we want the wall to do. It's the water control layer, it's the protection from wind, it's the structure, it's the aesthetic finish on the outside, and it's also the aesthetic finish on the inside. It does everything that the wall is going to do. It's one thing. And we don't build like that anymore. We've taken all of those functions and we've split them apart, and now we have different materials that do each of the functions that we want, and sometimes we pair them up and sometimes we split them up even more. But we've got a structure, and it's often for a house, it's wood usually. We have a different material that provides the insulation, a different material that provides a different kind of structural strength, right? You've got the frame, the wood studs, and then you've got sheathing for racking resistance. And then we've got a different water control layer, a different material that's the aesthetic finish on the outside, and a different material that's aesthetic finish on the inside. And when we mix all these materials together and all these functions become this mess of materials, we've created a lot of stuff we need to pay attention to, and how these things connect to different parts of the building, whereas it didn't used to really matter that much because it was just one solid mass. Now it really matters. And all these different materials, we create three-dimensional airflow networks within our walls, and we have to start paying attention. And we're doing this with moisture-sensitive materials, so we have to start paying attention to things that used to not matter. So it gets confusing really fast.
Yeah. Hence the building science. I want to share my screen one more time, and I'll bring up another post, and I'm going to put myself on the spot here because I want to know, to be honest, I didn't read through it all. So I'm just going to read the post and tell you what I think my answer is, but I don't really have a good answer as to why.
Okay.
And I want to know what the actual answer is.
We'll see if I remember the answer.
So you remember this one, I'm assuming?
I do indeed.
So to me, the answer to this question, so brick is an I'm reading it out loud because we're going to put this on our podcast later, but and I don't know if I can say absorptive.
Yeah, it absorbs
brick,
water.
Yeah, so brick, it is absorptive cladding. Pairing it with vapor, semi-permeable water, and air control membrane like zip is A, really good, B, really bad, C, neither good nor bad. For my response on this was, I would say neither good nor bad, I guess, in relation to how having the brick on that. I like having the air barrier there, not having to worry about it on the inside of the house and where all your plugs and switches and stuff go. But yeah, C would be my answer to this.
So the answer was not C, but your logic makes sense. For the way that you were approaching it is not is sound. The question was really more about not so much where you put your air barrier, because you're correct, you can put it all kinds of places. I prefer to have it on the outside like you. You sometimes also need air control on the inside in addition to that, but I like it on the outside for its ability to control all kinds of other things too. The question was more about is a membrane or a material like zip appropriate behind an absorptive cladding like brick.
Zip, maybe just to explain what zip is to people who don't know what zip sheathing is.
Oh yeah, you guys are in, they sell zip in Canada, I think.
We have zip. We've never actually used it on any of our products, so I'm familiar with it. But for anybody who's listening or watching, if they don't know what the zip sheathing is, can you explain maybe just quickly what it's, how it's?
So zip is an engineered wood product, and it's used as sheathing. So it's like standard OSB sheathing, but it comes with a factory applied coating that is green in color. It doesn't matter that it's green. I'm just telling you that it's green. It could be any color, but it's green, and it's this essentially, it's like a rubberized coating that's applied onto the panels of OSB in the factory, and the coating serves as an integral water and air control material so that when you install the sheathing, all that you need to do is tape the joints. So it's a little bit like getting the performance of a fluid applied product, but they apply the fluid in the factory, not in the field, and you just treat the joints in the field. The question comes up a lot in the South. We use a lot of brick in the South, and a lot of times we pair our brick with a water control layer behind the brick that is very vapor open in order to permit drying in both directions. And in general, that's a good thing. But you don't want it to be too vapor open, particularly in southern climates, because brick will hold a lot of water. And so you get a rainstorm and the brick gets wet and soaks up a bunch of water because it's very porous and will hold water. And then the sun comes out after a rain and beats down on the brick and warms it up, and that brick will want to dry, and it does dry, and it'll release water vapor in both directions, to the exterior, but also to the interior. So you'll have the sun pushing that water vapor to the interior of your house, and if your water and air control layer is something like the residential version of Tyvek, which is like 50 perms, it's very, very vapor open, that can end up being a real problem in hot, humid climates. So having any kind of water and air control membrane, including zip, this isn't a promotion for zip, but
Yeah.
having something that's less permeable than something that, like, Tyvek is kind of a crazy example because it's super, the residential, the home version is very, 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 very permeable. But basically anything else you use will restrict how much wetting can happen from reservoir claddings after a rainstorm. And zip is the coating is about 12 perms, which is 10 to 12 perms, which is a kind of a nice sweet spot for controlling exterior wetting from reservoir claddings. And it's primarily in southern climates. It matters also where you are too, but
Right.
it matters less. It also matters less if we do what we described before, conscious uncoupling. The more drainage and ventilation you have behind brick, the less it matters what the permeance of your water and air control layer is. So do a really good job at draining and back venting, and it doesn't matter as much. But as a designer, I like to I like to do both, because I can't always count. I don't know what the installation is going to be. I don't know how free of mortar droppings that cavity is going to be behind the brick. I don't know
Yeah.
how much ventilation
In a
I'm
perfect
actually
world,
going
you
to
have
get.
a perfectly vented area with no mortar that fell behind it, and
Exactly.
and it looks
And
just like the drawing.
it's also, it depends on what your role is on a project, right? If I'm a builder and I have control, I'm on site when this is happening and I am overseeing this work, I can be much more confident in that I'm going to get the installation that I demand because of my role on the project. And especially, that's even more so if I know the crew that's installing it because I chose them. I've done 20 other projects with them before. I know their work. I know, I can be more confident in that decision. But I advise architects on the design side, and they don't get to pick who oversees this stuff. So anything that we can, any safety factors that we can design into the system as opposed to install in the system is stuff that I care a lot about. But that doesn't mean it's to the exclusion of other things. But anyway,
Yeah. So I learn something new every day. So that makes a lot of sense, because those are things that we've thought about, but I never really thought about it in those hot, humid climates. We do have hot, humid summers here for a month or two. Like today was fairly hot. It wasn't too hot, but it was humid for sure. But then we also have the polar opposite, and we have dry, cold winters. Right. So we're kind of dealing with an interesting climate here where we have both extremes.
Yeah, it's actually, it's sort of becoming an issue in your climate because things are, like, our climate is changing, and things are getting hotter and more humid. And well, actually, I don't know. I'm not an expert at that, so I don't know. But things are getting hotter, and so if you're building with brick, even in Ottawa or Canada, if you're building with brick and you're using the residential version of Tyvek that's very, very vapor open, that principle happens the same way it does in southern climates. And what makes it worse for you, that is not the case down where we are, is that to control interior moisture during the winter, it's very common in Canada to have polyethylene vapor barriers on the inside. And if you've got poly, so you get a whole bunch of wetting, that brick gets wet and saturated, the sun comes out, drives that water to the interior. It goes through the water and air control membrane, through your sheathing, wafts through the cavity insulation, hits the poly that's now cold, and you get condensation forming and zero drying capacity to the interior. And that can be, so you can end up with a problem in Ottawa that we used to only have down where I am. We're exporting our problems to you, I guess. So you're welcome.
Yeah, we thought about certain things like that, and when we built our passo, so there's a product that CertainTeed makes.
Yep, membrane, love it.
Right? So we didn't
Great
use
stuff.
the whole thing. So what we did is there's a builder in Ontario, Terry, I'm trying to blank his last name. Anyways, he had used it. He did a strip in basement because he was being forced to put poly in basements too early, and the concrete was still drying, and he was getting condensation on the inside of his poly. And he did like a strip of the membrane, and then he just taped it on, and then it ended up drying within a week. So we did the same sort of thing where we just did a strip because it is expensive. So we put the poly on.
Fascinating.
So we cut out a strip, so we have that in our wall assembly. And it says because that stuff's like $150 a roll for
expensive.
Yeah. So
I wouldn't do. I don't like poly on the inside because we're just getting hotter. And I feel like it's a bad idea. But you're absolutely right. It's
the building officials don't know anything different, so they force us to do stuff. Luckily, I convinced ours to say like, look, I don't have to tape it. I already took control of my air barrier. I'm only taping it for air. And luckily, he had enough confidence in us. He was okay with it. But I've had other inspectors say, no, you have to tape these all. I'm like, no, I don't.
So in the U.S., we have a sort of a third option that's a little bit. That's a little easier, but it's hard to get this in Canada, is we get craft-faced bats, fiberglass bat insulation, and the craft facing works just like membrane, the CertainTeed product that's becomes more vapor open when it's exposed to higher relative humidities, so it permits drying, which is great. And it's not very expensive to get craft facing on the bats of the insulation that you're already using, and you just treat the seams. So it's a product that allows you to comply with the vapor barrier requirement in the code without actually creating this new summertime problem that poly creates. But in Canada, it's very hard to get that product. So you can't, we can do it really inexpensively in the US, but in Canada, unfortunately, your only recourse is expensive.
Right. We do have a question here that came up. Roy asked if about getting zip in Ontario, and Roy, yes, we can get zip in Ontario, but I think it's special order. I can't say I've walked into a hardware store, supply store in a long time. We're ordering everything, but we can definitely get zip, but it might be a special order, and you might have to order a certain amount in order to get it.
They've got a new product. I hope really takes off in Canada. Actually, it's called Zip R, and it's got polyisocyanurate insulation adhered to the back of the sheathing. So you get so it basically gives you continuous exterior insulation, but it's inboard of your sheathing. So you detail it the same way. You detail it, nothing changes. So, it is in your detailing, but you get this like way better performance out of your walls. It's cool.
I've read an article on polyisocyanurate, and that insulation from the article that I read, I think it was in Fine Home Building. I can't remember. Or no, sorry, Green Home Building. Anyways, I could probably find it again, but they talked about how polyiso actually loses a lot of its R value once it goes below -15 Celsius.
So yes, it does. That's true. But it only does that at the portion that's exposed to that big temperature differential. So essentially, if you're using an inch of polyisocyanurate, on the cold side, the outer quarter inch is susceptible to the reduced R value, only the coldest part. So if you're using an inch of polyisocyanurate, that can be a significant hit that you take in the thermal performance during the coldest part of the year. If you're using 2 inches, it's still only like as a percentage of the whole panel of insulation, not a whole lot. Relatively speaking, the reduction isn't as big. If you're using 4 inches, it's almost
So
irrelevant.
you only lose the first quarter inch?
I mean, I don't
Yeah.
know specifically if
Okay.
it's just a quarter of an inch, but it's the principle at play is that when this insulation is exposed to really high temperature differentials, in that it's very, the delta between one side of the insulation and the other side is very, very big, which only happens when it's very, very cold, right? The effectiveness of the insulation as a thermal resistor is reduced, but
Right.
it's not reduced evenly. It's not like the entire extent of whatever polyiso you're using is equally compromised over the whole thing. The most severe temperature differential occurs only at the outer edge. So the more of it that you use, the less this phenomenon matters.
And that's only if the delta is large. So if the delta, like if you had that as an exterior sheathing, but then you had a whole lot of insulation inside of that, that becomes less of a concern then?
Correct. Yes. Now
Okay.
it's
That's good
it's
to know.
not it's not that you shouldn't pay attention to this. It matters. It definitely matters, and it especially matters if you're using um, if you're really pursuing something extraordinary. You're going to want to know what the trade-off really is. But in most heavily insulated buildings, that the temperature effect of polyiso is too small to really worry about. Because you're already so insulated, it's not that big a deal. Now, other people take that is my opinion. Other people take a different approach, but the science behind it, that part's not an opinion. That's the temperature effect occurs where the temperature difference is greatest, and that is at the outer edge. It's not a linear thing across the whole extent of the insulation. Maybe it matters to you. If you're trying to decide between, polyiso has a very high R value per inch. So if you're trying to compare that to mineral wool, which has a lower R value per inch, um, that it's polyiso still a lot, has a much
Yeah.
higher R value per inch than mineral wool, but there are absolutely situations where it might make a situation where you were otherwise inclined to use something else more strong. Like it might push you in one way or the other, but that shouldn't be the only, I mean, it's never going to be the only
Yeah, no,
thing.
we kind of, yeah, exactly. That's what I was going to say. We like where there's a lot of factors, right? Like if we start we have clients who start looking into the carbon footprint, right? So then we're looking into different materials altogether, right? So there's so many things, so many factors, and
Yeah.
finding that sweet spot for homeowners is going to be different, especially in the custom world. And we didn't even really get into that. We got a little bit into that, but at this point, we've been chatting for a long time. We'll have to have you back on for a round 2 at some point. And yeah, thanks again. So for everyone who's been watching, definitely go to Christine's Instagram. It's Building Science Fight Club, all one word. It'll pop right up, I'm sure, once you start typing in building and then science. So yeah, any parting words of advice, Christine, or did you want to share anything else beyond your Instagram account?
No, I mean, I teach people on Instagram, so if you're interested in learning, please come on over, participate. It's meant to be a conversation, not just a lesson. It's how I get better at teaching as well. But it's a neat little community online. It's not just me. It's a neat community of people that have sort of informally gotten together and shared business practices and design practices in this sort of corner of the industry. And it helps to learn how people do things in different places and get better as a result. So I hope anybody who's interested in this, I think there's a fair amount of overlap there. So if you like this, you probably will like that community. And I would urge you not just to look at it, but to also join in, because it's everybody's got something to contribute here.
Love it. And for wherever you're watching, if you haven't already, share, like, what else can you do on Instagram? Share, like, and I don't know, high
Comments.
fives, comment.
Participate.
Yeah, comment,
Yeah.
participate. Christine and I would be very grateful for that. And we're also working on something called the Conscious Builder Academy. You can just head to consciousbulderacademy.com and check that out, and really just sign up for updates at this point. We don't have much to share yet. It's top secret. But yeah, so thank you so much again, Christine. Really appreciate it. And I will definitely be commenting and getting more involved with your page.
Well, you're no Gwyneth Paltrow, but we'll take that involvement. Thank you so much for having me, and good luck with your academy. I'm excited to know more. Thanks.